Examining the weather now on Discovery Science examines the repercussions of playing God with our climate.
Nothing is more terrifying than weather gone wild. Since the very beginning, we've searched for a way to manipulate Mother Nature. Now, thanks to the technological leaps of the last 3 decades, the holy grail of climate science may actually be within our reach as we strive to own the weather. Chaos theory hurricane control, advanced cloud seeding, massive ionospheric heaters, storm-absorbing supergels, nanoscale weather machines, some barely visible to the human eye. All of these technologies exist in some form today, and many of them are being tested at this very moment.
Whether we like it or not, the atmosphere is being modified by human activity. So we're living with it. We must do something about it. We don't have any alternative.
In many parts of the world, large-scale weather modification is already commonplace, and with good reason. If you've experienced Mother Nature's wrath, you'll need all the help you can get. Welcome to the Western Kansas Weather Modification Program, one of the largest in the world. Their speciality is cloud seeding, and their mission, hail prevention.
So we're concerned primarily, at least on this project here, with changing the dynamics of the cloud. Natural clouds are relatively inefficient at rain production, so they need a help from mankind, so to speak, and that's why we're here.
Farming is the lifeblood of Western Kansas, and hail is the enemy.
Now, Western Kansas has a very high frequency of hailstorms. It doesn't take a very large hailstone to do damage to a particular crop like wheat or corn. So we're making every effort we can to decrease the hail that falls out here so the crops have higher yields.
Those who've never experienced a serious hailstorm tend to underestimate the danger. The insurance industry knows just how damaging these storms can be. That's why they're one of cloud seeding's biggest supporters.
Hail damage is one of the largest damages that natural hazards produce. It's, I think, second only to hurricanes in the billions of dollars, like $2.5 billion a year. The insurance companies believe that they have reduced payments on damage in areas where hail reduction programs have been operating.
By forcing a storm to rain out quickly, seeding is the only real way to control hail. Cloud seeding is the oldest and simplest weather modification technology. But how does cloud seeding work? All clouds are made up of some form of water vapor. For raindrops or snow to form, a tiny impurity called a condensation nucleus must be present. Seeders use aeroplanes to inject impurities into the clouds. The water vapor forms droplets around these nuclei, eventually growing 100 times bigger, big enough for gravity to pull them from the sky. This is Tad Delsing. As one of the pilots flying out for today's seeding run, it's his job to prepare the plane. Along with typical fueling and flight check tasks, Delsing has to fill the silver iodide seeding tanks. Cloud seeding pilots are not typical aviators. They spend every day penetrating weather normal pilots avoid.
Unfortunately, doing this type of job, you're going to have some encounters, no matter how careful you are.
Pilot Kyle Spencer has had his fair share of frightening experiences.
Yeah, you just kind of do it like we aren't here.
Been struck by lightning numerous times. Most of the time the lightning will just hit like the wingtip of the aircraft.
Flying straight into the jaws of a storm cloud brings you face to face with the full force of nature.
My very first season, a hailstone came right through the windshield of my airplane and just grazed me on the neck and ended up in the back seat. Still about a baseball-sized hailstone laying in the back seat of the airplane.
Back at the Weather Center, Walt Geiger has a target in his sights, a cloud that's large enough to contain a supercooled region where water vapor is just waiting to freeze and grow into ice crystals, which later fall as rain. It's time to do battle with Mother Nature. Welcome to Kansas, home to the killer hailstone. Hailstorms cause immense damage to the farming industry, but there is an answer: cloud seeding. This ingenious technique forces a storm to end quickly before it turns deadly. But this technology is hardly cutting edge. In 1946, at the General Electric Research Facility in New York, Nobel Prize-winning scientist Irving Langmuir and two young scientists, Vincent Schaffer and Bernard Vonnegut, set out on a journey to make a cloud. Following strict guidelines, they filled a clean chamber with water vapor and set about their task, to no avail.
Then somebody accidentally put their hand in the pocket full of silver change and put that hand in the chamber, and bingo, there was a cloud.
The accidental introduction of silver dust offered the key, a tiny impurity around which water droplets begin to grow. Decades later, silver iodide particles are still one of the primary cloud seeding nuclei. In a standard seeding scenario, a cloud bottom plane flies below the base of the cloud and releases silver iodide particles into the warm rising updraft. A cloud top plane pierces the cloud core and drops dry ice directly into the supercooled vapor region at high altitude. And if all goes to plan, a downpour replaces the dreaded hailstorm. Back at the Weather Command Center, Walt Geiger finally sees what he's been waiting for: a front of large clouds. Pilots Kyle Spencer and Tad Delsing leap into action.
All right, clear out to the runway.
As Spencer heads for the high-altitude cloud tops, Delsing will cruise close to the ground in preparation.
All right, we are airborne. Wheels coming up.
When Delsing finds the exact location of the updraft, he'll fly directly into it. As the ride gets bumpy, he'll trigger silver iodide generators to release the agent, where it'll be carried thousands of meters up into the cloud. Meanwhile, Spencer prepares for the more difficult task by penetrating the body of the cloud. At this ultra-cold altitude, dry ice is an efficient seeding agent, forcing water vapor to freeze around it. If they hit their marks, both agents will provide a massive infusion of condensation nuclei, and the raindrops will begin to build. But even after 30 years of cloud seeding, some still question its effectiveness.
The problem you have in showing that it works in nature is that you can't do controlled experiments. So it's very difficult to say, if a seeded cloud rains, that it wouldn't have rained otherwise.
Even without definitive proof, cloud seeding continues to be practiced in over 30 countries worldwide. But this is stone-aged compared to today's technology. The most amazing of these new weather modification devices are so small, you might not even see one, even if it was floating in your eye. Ranging from the ultra-tiny to the nearly invisible, these are the revolutionary micro-machines that will be the workhorses of any world weather control system. They're MEMS, microelectric mechanical sensors. And there's more. Every day, 2,000 weather balloons are launched globally. They predict and potentially control our weather. But what if we could launch 10,000 or 10 million balloons? That's exactly the theory behind GEMS.
GEMS are Global Environmental MEMS sensors, a concept that we have come up with that deals with a massive wireless network of airborne probes.
The idea is to release 10,000 or more of these dust-sized probes every day from aeroplanes, stratospheric platforms or satellites. Like weather balloons, the probes would monitor weather information over every kilometer of the Earth's surface at a resolution that is today unheard of.
We envisioned that the GEMS probe itself would have a bio-inspired design, something like a maple seed or a dandelion seed that actually incorporates the constructs of nature to achieve aerodynamics and buoyancy.
With an ongoing stream of millions of measurements, the accuracy of our picture of the atmosphere could improve 1,000 times over.
There's every reason to be optimistic that simply having more measurements of the atmosphere will lead to improved forecasts.
It's also possible that the GEMS themselves could be made to play an active role in cloud dynamics, in effect, cloud seeding with 1 million microscopic computers. But if GEMS are heavier than air, what will happen when these millions of probes finally fall to Earth?
When the GEMS probes land on the surface, either in the water or on the land, they would continue potentially to provide surface observations.
But would they be harmful if accidentally inhaled?
At the sizes we're talking about, if you actually inhaled one or got one in your mouth or one in your eye, it would probably be no different than, say, a speck of dust or a particular particle in the atmosphere that you would get in. You'd probably sneeze it out or cough it up.
Nanotechnology will become indispensable to weather observation and prediction. But where cutting-edge science goes, the military is never far behind. There is a strong historical link between weather and war. In fact, for hundreds of years, people actually believed that battles caused rain.
There was a feeling that cannons going off could make it rain. Another theory was that as troops are battling, they're sweating a lot, and this is adding moisture to the air, which is true enough, so this added moisture could create rain.
However, there is a more concrete relationship between battles and rain. Just like silver iodide, the smoke and dust rising above battlefields are simply another form of cloud condensation nuclei. But could the weather be manipulated for military purposes? From Napoleon's defeat by the Russian winter to the Japanese use of a Pacific storm to cover the attack on Pearl Harbor, weather has played a vital role in battlefield tactics.
The military was always deeply concerned with the weather. Generals have been concerned about the weather since ancient times, and very rightly so. And so it was natural for them to go from finding ways to predict the weather better to thinking about ways that they might be able to change the weather.
As the nuclear age dawned, a new scientific era began to emerge.
Since the Cold War was beginning, there was also the possibility, well, maybe we can alter the weather over our enemy's territory for the worse. Maybe we can make it snow in Russia all the time. You know, they want a Cold War, let's give them a real Cold War.
This desire to use the newfound power over the environment gave birth to the first large-scale weather modification experiment, Project Cirrus.
Project Cirrus decided to seed a hurricane. And there was a hurricane off the coast of Georgia that seemed to be headed away from land. They flew a plane into it and they seeded the hurricane. And when I read the papers about what they did, I had the feeling that, gee, these people were like kids down in the basement with a chemistry set. You know, let's mix these things together and see what happens. What did happen is the hurricane made a sudden turn and came in and hit the Georgia coast near the city of Savannah, did a lot of damage.
One person was killed, 4,000 sought shelter, and 1,500 buildings were damaged or destroyed in a single 24-hour period in October 1947. By the end of the day, the US military classified the project and its data, effectively covering up the experiment. Scientists today believe that Project Cirrus's 36 kilos of dry ice probably had little effect on the hurricane. But for the military, the genie was out of the bottle. The dream of hurricane control lives on today in laboratories the world over as private inventors continue to hunt for a way to manipulate hurricanes. One of the most bizarre weather modification ideas comes from a tiny company called Dynomat, run by independent inventor Peter Cordoni.
We're going to demonstrate, here's the super absorbent that we created, and here is a bowl of water acting as moisture in a thunder system. And if you just go by sprinkling this on, you'll see instantly all the water is absorbed immediately.
Dynagel absorbs 2,000 times its own weight of water and locks it into a non-toxic gel. As the liquid solidifies, its temperature decreases by 10 to 15 degrees. Both of these unique properties could potentially draw energy from a storm cloud or hurricane. But what happens when the gel falls to Earth?
Here is ocean water right here. You see it'll dissolve it and reliquefy it immediately on contact.
To many, the product seemed too good to be true, so Dynomat quickly rushed it into testing.
This will be 3, 2, 1, drop.
It'd be interesting to see what happens when it hits that cloud.
On July the 19th, 2001, Dynomat dropped 4,000 kilos of their secret polymer into a storm cloud. According to observers, the cloud simply vanished off Doppler radar.
From this view, it looks like we lost a big section out. 1/9's flying around videoing it now. Looks real good.
When added to a cloud, Dynogel sucks up water and water vapor. Heavy with the captive water, the gel blobs simply drop from the sky. Dynomat's theory was that Dynogel could be added directly to the eye wall of a hurricane. The gel would capture the water vapor in the hurricane's upper regions and pull it to the ocean's surface, depriving the storm of the energy it gets from its condensation engine. But like cloud seeding, Dynogel's effectiveness is impossible to prove. Cloud behavior is simply too unpredictable to generate conclusive results.
Even if it does work, hurricanes are big, and some scientists at NOAA's Hurricane Research Division sat down and did some basic calculations, and they figured to even control a moderate-sized hurricane, you would need so much of this stuff it'd take from 350 to 400 C-5 transport planes. I don't even know if the Air Force has 400 C-5s.
And what if such an experiment were to go terribly wrong? It wouldn't be the first time. August the 15th, 1952, the RAF dispatched specially modified gliders to southwest England. Classified for decades afterwards, the gliders carried an experimental cloud seeding agent. The plan was to release it into an oncoming storm. Within 24 hours, the village of Lynmouth suffered 35 fatalities. The North Devon village had been virtually washed away. Although the British Ministry of Defence denied involvement at the time, recently declassified information has verified that the experiment took place. The Lynmouth flood pushed military weather modification into the headlines. Over a decade later, US military operations in Vietnam finally triggered the uproar that would spell the end of weather wars. Though they had denied it for more than 7 years, the US military had been using weather modification from 1966 onwards. The United States Air Force made over 2,600 top-secret cloud seeding flights. Codenamed Project Popeye, this clandestine operation attempted to turn key enemy transport roads to mud, rendering them impassable. They concentrated on the Ho Chi Minh Trail, a main supply line for the North Vietnamese.
They didn't just try to change the weather 1 or 2 days, they tried to change the whole climate over the Ho Chi Minh Trail by making it rain more there so that the North Vietnamese supply lines would get bogged down in mud.
Although absolute proof is impossible where weather is concerned, anecdotal evidence at the time suggested the US military were having success. As a result of the international uproar over Project Popeye, on the 10th of December 1976, the United Nations passed General Assembly Resolution 3172. It explicitly banned the use of weather modification in warfare. The weather wars were over, for now. It's estimated that 300,000 people die each year from hurricanes and related storm surge and flooding. Worldwide hurricane damage since 1980 is estimated to have exceeded $1 trillion. The amount of energy generated by one ordinary average hurricane is enough to run the entire world's electrical grid, a staggering 2 billion watts. It's impossible to stop a hurricane, but just maybe we can control one. In the mid-1960s, Bob Simpson, head of the US Hurricane Research Program, and his wife Joanne, one of the world's leading tropical weather researchers, set out to do just that. The project, jointly overseen by the US Navy, the US Weather Bureau, and the National Science Foundation, was called Storm Fury.
The fundamental concept of Storm Fury was that if you take a ballerina who spins up, she spins up by bringing her arms and her legs close to her body, conserving what a physicist would call angular momentum, and she goes into a blur of a spin. The hurricane eye is drawing in the air into the eye and spinning up the core of the hurricane. It's basically the same process. The concept of modifying that was if you could stop that ballerina from pulling her arms in, she couldn't spin up.
The Simpsons set out to seed a ring of clouds outside the hurricane's eye wall, creating a bigger, slower, and less powerful replacement eye wall.
In each case, when they did try it, they saw a reduction in wind speed, as much as 15%.
But the experiment was dangerous. It required pilots to do just what they'd been trained to avoid: fly directly into a hurricane.
When we fly in a hurricane, we're mostly, if we're in near the center, in light to moderate turbulence. This is fasten your seatbelt on a commercial airliner turbulence, and every 2 or 3 years in the course of a hurricane flight, you'll get into severe turbulence, and that gets your attention. That's where the lady sitting behind you screams on the commercial airliner.
Project Storm Fury seeded hurricanes over the course of almost 21 years. Their results showed promise, but by the early 1980s, political pressure and the demand for absolute proof shut down the project. What was needed was a new approach. The technological revolution of the 1990s made satellites and accurate weather prediction an everyday occurrence. But what if we could use this data not only to forecast the weather, but to change it? It's estimated that 300,000 people die each year from hurricanes. Worldwide, hurricane damage since 1980 is estimated to have exceeded $1 trillion. By the 1990s, the proliferation of satellites made it possible to predict weather accurately.
There are several weather centers around the world that use global models to forecast the weather. And at these centers, they collect data of many different types. These data include observations from radiosondes, which are balloons that carry instruments into the atmosphere, observations from aircraft, many observations from satellites. Satellites don't just provide us pictures of the clouds, they also remotely sense the temperature and humidity in the atmosphere at different levels in the atmosphere, as well as quantities on the surface, such as sea surface temperature and the winds on the ocean surface.
By sharing this massive quantity of data, scientists around the world can create a snapshot of the weather as it is at any one time. But what if we could use this data not only to predict the weather, but to change it? Welcome to Atmospheric and Environmental Research. It's here that principal scientist Ross Hoffman steers hurricanes. Using supercomputer modeling, Hoffman tinkers with hurricanes based on old recorded data. Algorithms tell him what tiny change should generate a predictable result, and he enters that change into the model. Then he sits back and waits to see if this tiny change triggers a big effect. In essence, he is steering hurricanes from the past.
We looked at Hurricane Iniki, which struck the Hawaiian Islands in 1991, and Hurricane Andrew, which devastated Florida. In our first experiment, we just tried to simulate the hurricane, and we attempt to forecast it for several days. And usually we can do a fairly good job of that because there are good data sets for these historically important hurricanes. Then we attempt to find a small change at the start of our forecast, which has the effect of either weakening the hurricane or changing its position sometime in the future. We want to find situations that are sensitive to initial conditions, situations where small changes at one time can lead to much larger changes later on.
The concept of predicting the tiny action needed to produce a huge result is a central idea in a growing field called chaos theory.
One of the things that makes weather prediction very difficult is that the weather system is chaotic. And this means that very small inaccuracies in our observations can grow very, very quickly.
The proverbial butterfly flaps its wings in Peru, and the slight air disturbance sets off a cascade of effects, causing a tornado 3 weeks later in Texas. Predicting the exact string of events connecting the butterfly wing to the tornado is one goal of chaos theory.
And so we allowed all different possible changes, including changes to the winds, changes to the temperature, changes to the water. The greatest thing was the first time we tried to move Hurricane Iniki, and my goodness, it actually moved where we asked it to move.
But Hoffman can't accomplish his goal alone. Even if he can predict the exact location of the tiny environmental change necessary to steer the hurricane, he still needs to work out how to make that change in the real world.
Hurricanes get their power from the evaporation of seawater. It's everyone's common experience that if you get out of a swimming pool, you're wet. And even if it's a hot day, you can feel cold, particularly if it's windy, because the evaporation of water from your skin is drawing heat out of your body. Well, exactly the same thing happens over the ocean in a hurricane. The winds of the hurricane evaporate seawater and draw heat out of the ocean. That water vapor condenses into cloud in the eye wall of the hurricane. And the faster the wind blows, the more water evaporates and the more energy is supplied to the storm. It occurred to us that it might be possible to modify artificially the rate at which water evaporates.
This may be exactly the small change that Ross Hoffman needs.
The idea is to coat the surface of the water with a substance, maybe only one molecule thick, which would have the effect of slowing down evaporation. Benjamin Franklin discovered already that a teaspoon of olive oil would cover a whole lake, because if you're only got to have it one molecule thick, a little bit of substance goes a long way. So the question we had is whether we could come up with something that would hold together at these extraordinary wind speeds.
For a protective coating to be effective, Emmanuel believes that it would need to persist for at least 6 hours.
The effect would be ideally as though the hurricane made landfall 24 hours before it really did. You know, everyone knows the hurricanes fall apart pretty quickly after they make landfall, precisely because there's no more ocean left to evaporate. We're really doing the same thing artificially.
If successful, this technology could save thousands of lives. But there are other weather-related technologies that have a darker side. Bernard Eastland is a plasma physicist, former fusion researcher for the US Atomic Energy Commission, and inventor who has 3 weather control patents. Eastland's speciality is revolutionary mechanisms of energy transfer. That was exactly the reason that the Atlantic Richfield Oil Company approached him with a unique problem to solve.
I was originally hired by ARCO in about 1984 to find a use of their natural gas on the North Slope of Alaska. They have 23 trillion cubic feet of natural gas.
To put this in perspective, that's enough gas to power the entire American electrical grid for 1 year. But its location was so remote, there was no economically feasible way to transport it.
Dr. Eastland had been contracted with them to find a way to exploit the natural gas on the North Slope. In other words, to convert natural gas to money, but first to turn it to electricity and then radio frequency energy.
I came up with the idea of using the energy in the gas to make electricity, and to use the electricity to power a large phased array antenna that could modify the ionosphere in different ways.
Eastland's massive antenna array was called HAARP, the High Frequency Active Auroral Research Project.
The claims being made about the technology were such that it was almost unbelievable.
Although the HAARP antenna array looks unremarkable, its capabilities are not. HAARP is one of the few man-made devices capable of heating the Earth's ionosphere. The ionosphere is an enveloping layer of charged particles located 145 kilometers above the surface of the Earth. The charged particles in the ionosphere perform an important function for the planet. They deflect and absorb the solar wind, the toxic onslaught of deadly particles thrown at us by the sun. Without the ionosphere, life as we know it on Earth would perish. Eastland's plan was to pump energy derived from natural gas directly into the ionosphere. The stated goal was communications research. ARCO immediately understood the genius in Eastland's idea, and thanks to his patent, they were contracted by the US military to build this incredible device.
It's a very good research facility. It's minuscule compared to the size of antenna I suggested in my patents. However, it's the first piece of what could become something bigger.
But even in its current incarnation, it's the largest ionospheric heater in the world, capable of heating a 1,000 square kilometer area of the ionosphere to over 50,000 degrees.
It's also a phased array, which means it's steerable and it can point where it wants to point. You can make those waves go where you want.
What they have found is that by sending radio frequency energy up and focusing it as they do with these kinds of instruments, it causes a heating effect. And that heating literally lifts the ionosphere within a 30-mile diameter area, therein changing localized pressure systems or perhaps the route of jet streams. The idea of moving a jet stream is a phenomenal event in terms of man being able to do this. The problem is we cannot model the system adequately.
Long-term consequences of ionospheric heating are unknown.
Changing weather in one place can have a devastating downstream effect.
And HAARP has already been accused of modifying the weather. An article in Scientific American pointed out that a strange shift in the jet stream directly over Gakona, Alaska, pushed colder air southward, causing a rare tornado outbreak in Florida. As a weapon of war, HAARP's possible uses are daunting.
Think about a 100,000 person army and your opposition, and say you could hit them with flooding rains and horrible conditions in terms of weather for several weeks, maybe months. You can degrade their ability to perform in the battlefield.
HAARP has other implications as a multi-purpose weapon. Using ionospheric manipulation, it could disrupt enemy radio and cellular communication. It could even be used to sense, differentiate, and directly destroy enemy missiles.
That's where war is headed in the 21st century. That's where these systems are headed in the 21st century.
HAARP's potential role as a secret weapon of war has long been known in military circles. Numerous countries have lodged complaints against its use, pointing to it as an obvious violation of the treaty outlawing environmental modification for weapons applications.
The last 3 secretaries of defense have all called for the elimination, the dropping of this environmental treaty. This treaty was well thought out in the early 70s, ratified by our Congress in 78. That treaty needs to stay in effect.
Through all of the controversy, HAARP scientists have maintained that the array is intended only for pure research, and that it has nowhere near the power necessary to truly change the weather. However, as the results would be classified anyway, the jury is still out. And the American military interest in weather modification doesn't end with HAARP. At this base in Florida, Air Force weapons researchers and nanoparticle specialists are conducting weather control experiments. But their goal is quite surprising.
We are an explosives laboratory that are developing the next generation explosives for the Air Force. Penetration warheads, air blast bombs, just a whole grouping of different type of munitions. And the purpose, obviously, is to destroy things and to stop the enemy. That's what we do. That's what the Air Force's mission role is to win wars and break things, right?
But in this instance, Glenn is talking about breaking something unusual, a tornado.
In 1999, there was a tornado that ripped through Oklahoma City, Norman, Oklahoma area. It was $1.3 billion worth of damage. Lots of people dead. I thought, why do we have to always have a defensive role here? Why couldn't we maybe look at it as an offensive role?
Glenn's first idea was to use the tools he knew. Why not just blow up a tornado to disrupt its airflow and force it to dissipate?
We found in our initial calculations that the energy required was tremendous. We were not able to really get any kind of reasonable amount of change or perturbation in the flow field.
Glenn began to investigate the science of tornado development. He found that one school of scientists strongly believed that the energy released by lightning strikes was the engine that created tornadoes.
We believe the development of a tornado and the sustaining of a tornado was basically powered by the lightning itself. Now here's what we're saying. If we can forestall or interrupt that final stage of right before that trigger fires that tornado, if we could interrupt that, slow it down in some way, could we conceivably prevent the tornado from forming?
To accomplish this interruption, Greg Glenn suggests a massive nanoparticle infusion directly into the intracloud chamber where lightning would begin to brew a tornado. The particles he suggests are fly ash, an inexpensive byproduct of industrial combustion. Unlike standard cloud seeding materials, the purpose of these microscopic insulators is not to promote rain.
What we're basically trying to do is short circuit the final phase of that tornado formation. Short circuit.
No, you don't. But watch out for...
While US Air Force researcher Greg Glenn focuses his nanoscale expertise on the tornado, scientists worldwide confront what may be our most daunting weather challenge: global warming. Anyone who's experienced the fury of a tornado knows just how inhospitable the Earth can be. And weather researchers tell us it may be getting worse. In the American state of Oklahoma alone, data shows a more than 400% increase in tornadoes since the mid-1940s. For many, this is just one of the sobering effects of global warming. Although global warming is now accepted internationally as a potentially deadly phenomenon, 100 years ago, many scientists actually thought global warming could be used as a constructive tool.
People proposed that we dig up extra coal in order to warm the climate up, dig up coal and burn it at the surface. The thinking was people burned more fossil fuels, it would warm the planet up and it would push the limits of agriculture northwards so people could grow more food for an expanding population in a positive way.
But the idea of turning the Arctic into a garden by burning fossil fuels was short-lived.
In the mid-1950s, especially with the coming of the nuclear bomb and of chemical pollutants, it appeared that we could turn gardens into deserts. We no longer saw ourselves as in our garden surrounded by an encroaching savage nature and battling it back. Rather, we saw ourselves as the potential danger, and nature is what was being surrounded and beaten back.
If global warming is a measure, the signs that we've defeated nature are everywhere.
The current consensus, and I must emphasize that it is a consensus in which almost all scientists, even many of the so-called skeptics, will sign into, it is likely that 100 years from now the world will be very substantially warmer. And it's further widespread consensus that this change may not happen continuously, that sometime between next year and 100 years from now there will be a lurch in the system.
It appears over the next century, the greatest modification challenge may be controlling the environment to counteract the inevitable damage humans will cause. Not surprisingly, there are a host of massive geoengineering projects on the drawing board to do just that. One proposal suggests purposefully injecting large amounts of specialized dust into the upper atmosphere, essentially mimicking an enormous volcanic eruption. When a volcano erupts, it inundates the atmosphere with ash particles. These particles reflect sunlight back into space and block it from hitting the ground, causing a rapid cooling of the planet.
We saw the Earth cool quite dramatically in a period of a year or so after the Pinatubo explosion. It's easy to observe. And so people have long proposed since the mid-60s that you could artificially add dust to the stratosphere and cool the planet. Not that this would be a good solution for global warming, it would not. But it does show the way we're steadily developing the powers to manipulate the planet with comparative ease.
If we don't solve the global warming problem, making our nearest planetary neighbor hospitable is, to some, a challenge to be embraced.
When we look around our solar system and imagine where might life go next, well, Mars comes up as an obvious candidate.
The idea of terraforming Mars, changing its weather and building a breathable atmosphere from scratch, is not as far-fetched as you might think.
Well, the basic problem with making Mars habitable is warming it up. Well, we know how to warm up planets. We're doing it here on Earth. Well, on Earth it's probably not a good idea, but on Mars it would be just what would be needed. So one could imagine releasing into the Mars atmosphere the same kind of super greenhouse gases that we're releasing into our atmosphere. Our calculations using climate models suggest that we need to push Mars artificially about 20 degrees centigrade. We need to do that with these super greenhouse gases. Once we push it that far, it will then roll on its own the rest of the way.
Mars's polar ice caps contain vast stores of frozen carbon dioxide and substantial water. These would be the basic building blocks of a habitable Mars. As the water trapped in Mars's polar regions began to melt, it would create massive natural oceans. For NASA scientists like Chris Mackay, the concept of terraforming Mars as a human habitat is not simply a dream, it's an inevitable requirement for species survival. But there are many difficult questions still to be answered. None more than, do we have a right to do with Mars whatever we please?
Should we do it? Given that I think we can do it, should we do it? To me, the best analogy is doing CPR. You're walking down the street, someone falls over dead, or you found a body there, you go and bring it back to life. You haven't created a human being. You've restored a human being to life. And I think that's the appropriate metaphor for Mars. And other people might disagree. Other people might think that it is not our place to change the universe. That there's a big sign, do not touch, hanging all over everything. But I personally think that the value of life is a stronger one. That the universe is not to be preserved, but to be gardened, and that we are the gardeners.
But if that's the case, perhaps we should start in our own garden.
I think in general, at a very high level, we have no choice but to assume management responsibilities for the Earth. There are just too many of us, we live in too many places, and we have too much of an impact to just let nature run its course. That's really not an option anymore.
Whether we like it or not, The atmosphere is being modified by human activity, inadvertent modification. So we are living with it. We must do something about it.
Chemically fertilizing the oceans, beaming microwaves to Earth, covering the ocean's surface with polymers, steering hurricanes. None of these are far-fetched. But will science lead us to the next golden era or to absolute devastation? When we finally own the weather, what will we do with it?